As soon as the Hubble Space Telescope was launched, astronomers were clamoring to see what it could do. The problem was, there was only so much observing time to go around.
It was still not clear if you just took what we call a blank field, some indistinguished field of the sky, and sat Hubble on it and took picture after picture, electronically added them for a period of 10 days, that you would come up with something that people would say, yeah, this was worth it.
A job like that meant other projects would have to wait their turn.
Telescopes are time machines because they look back to earlier times. The light has been traveling for such a long time to get to us that it left a long time ago.
We had a theory that said that galaxies should look really different back in time. They should be smaller, they should be bluer, and they should be more irregular because they were still accumulating as the mass fell together via gravity. All three of those predictions were confirmed in the very first Hubble pictures. That was really my gotcha moment. It was great.
The galaxies were much smaller, much more distorted, if you like. They weren't really galaxies. They were just pieces of stuff, star clusters coming together to form galaxies.
The first images that were taken in the mid-90s were eye-opening, but then we put a new camera on in 2002, and that just was hugely different. Bigger, better, brighter, more distant.
While that follow-on deep field image added to our understanding of the early universe, it was the last servicing mission in 2009 that allowed us to see all the way back to when the universe was essentially a toddler.
They put on this new wide-field camera, and that gave it an infrared sensitivity, and suddenly we were back to within 500 million years of the Big Bang.
If you think of human development, the difference in looking at a toddler between 1 year and 2 years, or 6 months and 2 years, is enormous. So even though it's only going back another couple of billion years, you're actually looking at something in a much more nascent state of development.
As the development of the cosmos continues to be a burning question, astronomers are getting another assist from the universe itself.
Instead of looking at essentially an unspecial piece of sky, they proposed looking at a very special place, the fields around strong lensing clusters, the most massive objects in the universe. And Einstein's theory of general relativity tells us that space and time is bent around those objects. And so they can actually act as natural telescopes, bending the light and magnifying the light from galaxies that are behind that. Basically, we're using Hubble in combination with nature's telescopes to see farther than we could possibly see with Hubble alone.
The so-called deep fields are the longest images ever taken of the universe and some of the most informative pictures ever taken by human beings. They're a real milestone in the course of human science.
While Hubble is still showing how the universe has evolved over billions of years, there's still much we don't know.
We haven't found the very first generation of galaxies. That would be an amazing time. We call it cosmic dawn, when the universe switched on starlight for the first time. Now, was this a sudden moment? Did the universe suddenly go from darkness to light? Or was it a gradual process?
Answers to these questions and many more will have to wait until Hubble's successor, the James Webb Space Telescope, takes over the reins as it's primed with infrared vision to look even farther back in time. From the Space Telescope Science Institute in Baltimore, Maryland, I'm Mary Estacion.